It's my pleasure to welcome Jan from OpenAI. He leads the alignment team there, and he was previously a researcher at DeepMind as well. Holds a PhD in reinforcement learning theory. Has been thinking about the alignment problem for over 10 years. And today he'll be giving a very interesting talk. So hope you guys enjoy.
Yeah, thanks a lot for the intro, and thanks a lot for having me. I'm very excited to talk about this stuff. I'm also super happy to keep it interactive. If you have questions at any point, please interrupt me. And yeah, I want to start out with a few very basic observations on kind of what I think is going on. And so the first one is Team AI is joining the game. So Team AI has a lot of different players. They don't all join at the same time, but rather they join one by one. And not all of their players are like vary a lot in how good they are. And right now, a lot of the players that have joined so far aren't really that smart and usually can do only a very narrow set of tasks. But one thing that we've kind of observed is that over time, we're seeing stronger and stronger players join. And this is kind of where we are now. And then in general, we expect that Team AI has some incredibly strong players. So those will be players that are able to think so much better than humans, so much faster, and so much more cheaply. And these haven't joined yet. And so the kind of like anchor point that we have, if you think, for example, about ChatGPT can already beat any human at like knowing more facts or speaking more languages. And it can write about 50 words per second, and it can do so about 100 times cheaper than humans could at minimum wage. And so, there's the more ChatGPT also has some really important limitations, and there's a lot of things that it can't do yet. But it is kind of an indicator of some of the players that maybe will be joining in the future. And so it seems like in the long run, Team AI will have all the advantages over Team Human. But, and there's an important caveat, which is there's one important advantage that Team Human has, which is Team Human gets to pick which players from Team AI join and when. And so this is kind of like an advantage that we should really be leaning into when we're thinking about what to do, and when we're thinking about this game that we're playing with Team AI and that we'll be playing with Team AI in the future. So I think two of the main objectives of what we as Team Human should do is like, first, we should try to recruit players from Team AI to play on Team Human. And so this is kind of what I would broadly call alignment. And this is kind of like the problem that I'm working on. And then there's also other objectives. So another objective that I think is going to be really important is you want to write the rules of the game so that Team Human doesn't lose. And right now, Team Human kind of has the ball, and we get to write the rules. So we should write rules that make sense and let us still play this game in the future. And so in this talk, I won't really talk about the second point at all. And I will talk about the first point, because that's what I know best and that's what I'm working on. And kind of to phrase it differently, or to make it kind of like more tractable, like one way I'm thinking about alignment is like we want to build AI systems that follow human intent and that, follow human preferences that do what we want them to do. And so a bunch of the things, basically, I'll talk about two main things. The first part is going to be work that we've done in the past, and kind of like, which roughly is in the bucket of like, we are trying to figure out how we can make the models that we have today as aligned as we can. And we're just kind of we're going to try hard to do this, and we'll see how far we get. And then the second bucket is the things that we have to do next. The stuff that we haven't done yet that we think are going to be really important. And I want to kind of like lay out why I think they're going to be important. So now I said, I'm like trying to make this more clear or like more broken down what alignment means. Still not that clear, because now, the big question is like, what does it mean to follow human intent? And kind of like two main categories of intent that we care about is, I would say, explicit intent. So if like I give the system an instruction, or if it wanted to be my assistant, it should be my assistant. I should follow the instruction. But then there's also all these other intents there. And don't say when I'm usually, talking to a system or a human, that I also really care about. Like, it shouldn't literally always do what I say, but thing that I mean, and it shouldn't make up stuff, and it shouldn't, do harmful things, and it should ask follow-up questions when it's not sure what I mean, and so on and so on. And so these are all kind of like things that are often just like really difficult to like just precisely specify or like put precisely in words. But it is still things that we want to get AI to do and that we have to figure out how to, get into it. And so kind of like the main technique that we're using today for this is what we call the reinforcement learning feedback. So that was used to train InstructGPT and ChatGPT, which are the two like main systems I'll talk about in this part. And the basic system is very simple, and it's also like a super general technique that applies to lots of different AI models and modalities and settings. But in this case, we'll be using managed models. And so two steps. There's actually another step of like training and demonstration. So I'm going to just stop for the sake of simplicity. First step is you want to train a reward model from comparison. So you have a bunch of tasks. In this case, explain moon landing to a 6-year-old, or have to help me with my term paper, whatever it is. And then the model does a bunch of things, and then you rate which one is like closer to the thing that you intended the model to do. And so you have the bigger set of preferences, and you train a reward model. And the reward model basically just learns to predict which one would you prefer. Everything okay?
Yes, good. I would say just stand more in front of the camera because you're not visible, but I think that looks good.
Sorry about that. Maybe let's turn it a little bit this way. Okay. So now we have this reward model that captures kind of our preferences and what we care about and what we intend for the model to do. And then the second step is now you optimize the reward model with the reinforcement learning. And so in that setting, like model tries a whole bunch of different things, and the reward model kind of tells it which one of these things is probably more like the thing that the user cares about. Yes.
When you say comparison, is that made by a human labeler? Goes into data. Okay. And are those always consistent, or does that sometimes depend on the label?
They'll depend on the labeler. Different labelers will have different preferences. There also might be inconsistencies, and you can give these examples of like intransitive preferences. But those haven't really been a problem in practice. And so far, like our labelers often don't agree, but the model will average over all the preferences the labelers have. But yeah, so this is like the basic technique. It's conceptually like quite simple. You can make it even simpler if you had, if you didn't train the reward model and you labeled instead like every RL episode. But it would be a lot less data efficient. And so you can, training your reward model to think of like a data efficient. Yeah. So how will this work? So this is kind of like one of the main thoughts from the InstructGPT paper, and this is the one I like showing because it really blew my mind, and it still does. What do we see here? So on the x-axis, you see this is from the GPT-3 model series, and you see this is like three different sizes of models over 2 orders of magnitude. And on the y-axis is how well does the model score on human preferences. So if we show a bunch of samples to humans, how likely are they to prefer one over the other? And then what we see is that even like the largest GPT-3 model is dispreferred to the smallest instruct GPT variant. And so the 100x smaller instruct model is actually preferred over the much larger GPT, full-size GPT-3 model. And that's kind of wild. Sorry, let me just finish my thought. So why is this a big deal? So basically, this basically shows that there was like a field aligned overhang in the sense that making the models more aligned made them so much more useful than just field scaling out and fine-tuning. Or fine-tuning makes the model worse, then nobody want to use it. And
can you guys hear me?
We make all these fancy alignment techniques that don't get adopted. And so what we were originally, the first version, we did saw these regressions, and then what here is labeled PPO PKX is kind of like a variant where we mix in pre-training data into the fine-tuning, and that mitigated a bunch of the regressions that we saw. Yeah.
And I just had a quick follow-up to that. How important is fidelity of fine-tuned data that you have? You collect data from humans, right?
Yeah.
What if you were to use some pre-trained language model to score, generate data for the reports or something like that?
Yeah. You could do that, and there have been other papers on that. Anthropic wrote this paper on constitutional AI that was trying to exactly do that. In terms of, there are certain things that the language model will be able to automatically rank, and some things it won't, because it won't know your exact preferences, or it won't know exactly what we want it to do. And so, whenever the language model does something that we disprefer, we have to give it another data point, right? Or in other words, if you're aligning with humans, you somehow have to put humans into the loop so that, otherwise, how does the model know what it's supposed to do? Okay, lots of more questions. I don't know who was first. Yeah.
How many approximately how many orders of magnitude of human preferences do you need to achieve these?
Yes, I'm gonna get to that in a second.
Sure.
I have a question also related, especially with your PPO here.
Yeah.
I think not as sample efficient as some other.
Yeah.
So why do you decide to use this experiment theory first?
We haven't actually carefully compared across RL algorithms. And it could very well be that a different RL algorithm would be better. That was kind of I don't know, PPO was invented OpenAI, so that's why we used it. It's not a really good reason other than that. It works also pretty well. Yes.
What are the labels that humans are using to comes up, comes down?
Comparisons. This is better than this other thing. So usually we have people compare between 3 to 6 different responses from usually different models. Yeah.
So is PPO and the reward model currently used in ChatGPT in production? And if so, do you use any of the human feedback, you can regenerate responses and stuff like that to help as a reward function as well?
How do you mean to regenerate?
There's a button on ChatGPT where you can say regenerate responses, or do you use any implicit feedback basically in human use?
I don't know what the current state is for that. I expect people will try to use it, but ChatGPT hasn't been out that long. Yeah.
So I'm curious about this graph. It seems like 100x, as you mentioned, increasing parameter doesn't give you that much more fidelity there. Qualitatively, you have been tracking this for a while. Can you tell right off the bat if you're interacting with the 1 billion a model or the 100 billion model, a pseudo Turing test but for parameter size? I give you a black box. Can you tell me how many parameters it has?
Probably not very precisely, but I think the big counter question is do I get to write the prompt?
I see.
So if you just draw random prompts from whatever people put in the OpenAI playground, which is what we use for InstructGPT, then I probably need quite a few to tell the difference. But if I get to write the prompt, I can probably do it in 1 or 2. At least like if the task is like tell the difference between this and this. Yeah. Can I just do 2 more slides and maybe your questions get answered? And then, so this was the question about training costs. So this is another thing that kind of really blew my mind is like, compared to pre-training, it is incredibly cheap. So if you look at like the amount of flops that it takes to train GPT-3, and then you compare it with like how much is fine-tuning and the RL with pre-training mix and everything, like the most expensive InstructGPT version is like less than 2% of the pre-training compute. And if you want to train an even bigger model, it's going to be more expensive, and you could still use the same like fine-tuning step to make it more aligned. And of course, I think the important thing to note also here is like we haven't fixed all the problems. There's like important limitations. And so I wouldn't say that this is like, you know, the last version and we wouldn't try to figure out how to spend more compute and more human data in the future. But all in all, it was surprisingly effective. Okay, there were no more questions. More questions? Yeah.
I just wanted to ask what the PTX
mix in pre-training data into the RL fine-tune, just like mix the gradients. Yep.
Quick one, what's the number of parameters for this graph? So you fix the number of parameters for this graph.
So this is the full-size GPT-3 version. So this is the 175 billion model. More questions? No? Okay.
Oh, there's also some questions on Zoom.
Great.
Let's see. Yeah. Okay, sure. So the first one is, okay, sure. So the first question is, how would you deal with RLFH breaking in the limit? Example preferences are a good proxy for values, but optimizing for them is theorized to incentivize perception.
Yes, I'll get to that.
Okay. Sure. Sure. Next question. So that is like, you want to automate alignment research. What happens if we need conceptual breakthroughs, which are difficult for experts to verify?
Okay, that would be I get to take at the end as well.
Sure. Let's see.
Sorry.
Yeah, I guess like one question is like, how would fine-tuning directly on human feedback compared to fine-tuning with RL?
Fine-tuning, like supervised fine-tuning?
I think it's more like if you directly use the human feedback data. Yeah, I'm also not sure what they mean.
Okay. So one baseline I'm showing here is like, what if you just take human demonstrations in the sense that, you know, we have a bunch of tasks, we just ask humans to do them, record what they did, and then train the model to imitate that. And here it's like just very basic behavioral cloning, just using the same loss they use in pre-training. And then, you know, is noticeably better than the few-shot prompted version, but it's still not as good as RL. And so that's why we like using RL. And basically, conceptually, there's 2 problems with the imitating humans approach. One is humans are better at some things than the model is, and they're worse at other things. And so at the things that the model is worse, you're trying to imitate something that you can't do. And on the things where the model is better, you're making the model worse because you're forcing it to do the thing in the way that the human would. And so with RL, with RLHF, you're kind of letting the model do whatever it wants to, and it can just figure out like the best way for it to do things. There's also another important advantage, and I'm going to get to that, but I briefly want to talk about ChatGPT. So one thing, I kind of think of ChatGPT as like the upgrade to InstructGPT. It's kind of like the next step at making the models more aligned and more useful to humans. And some things that is like, you know, I think Chat does better is kind of like using dialogue as the universal interface, right? You can talk to it directly. You can ask follow-up questions. You can, you know, ask it to, you know, refine the answer and all these things. That makes it a lot easier to deal with. It's better at refusing harmful tasks, but it's also, there's still important limitations, right? Like the biggest one is like the model hallucinates a lot. It makes up facts when, you know, for whatever task you give it, and that, you know, makes it quite unreliable. It's also still sensitive to prompting, which kind of shows that it still has important misalignment that we need to fix. Like really, if the model was like, the model should really like do the task to the best of its ability, no matter how you prompt it to do that. But yeah, one important principle that I think is really useful for, or that like RLHF leans on a lot, is that evaluation is easier than generation. So if we ask humans to compare and rank different responses the model gave, it is easier to tell the difference between different variants of what the model did than it is to do the task itself. Or in other words, you can do the comparisons on tasks. You can still like spot good behavior on tasks that you might not be able to do well yourself. And so if you're giving this kind of like feedback that lets the system to do better than you actually could. And I think that's a very general principle that holds in lots of domains. So kind of like you're probably most familiar, if you study CS, the P versus NP, and everyone, we don't actually know whether they're different, but in practice, it seems like NP tasks are just much harder. It also applies to lots of other settings, like a lot of professional sports or esports just wouldn't be fun to watch if you couldn't tell who's winning more easily than you could actually compete on a professional level. It applies to a lot of consumer products. You can like look at your smartphones and tell which one you like more. That is like also deeper than just looking at like the specs. But it is actually very hard to build a good smartphone. It also applies to academic research. It's much easier to review a paper and say what all the things that are bad about it than it is to write a good paper yourself. It applies to, I don't know, when you, basically there's lots of domains where this applies. And so I think this is like this principle is like very useful when we want to like align AI systems on tasks that we might not be able to do ourselves well. Okay, so having said that, RLHF has some really important limitations. And I think that's going to make it really difficult to use RLHF to scale alignment. Let me explain this with a diagram. So basically, on the x-axis, let's plot like the AI progress. And on the y-axis, how difficult different tasks are. And then as we have more AI progress, kind of like the difficulty of tasks that AI can do goes up. And like one of the fundamental problems is that the level of tasks that humans can reliably evaluate doesn't go up because humans don't get better with AI progress. And so I think we're like somewhere here. But the problem is once you cross this line, you don't really know whether your model is actually doing the right thing because you can't reliably evaluate it anymore. And so that's kind of like the point where RLHF training will start to break down. And what we'll probably see is kind of what the question before I alluded to is like, well, now the systems are optimized for whatever feedback we give them. And so they will try to tell us what we want to hear, rather all the things that they know to be true. And, they might learn how to deceive us because, that makes it easier to score higher on preferences. And so kind of like the basic idea that we want to leverage is related to the principle I just mentioned, which is evaluation is easier in generation. So for example, if you have a large language model writing a code base, like an entire code base, there's just no way humans would be able to find all the bugs and all the flaws in the code base, or the code base could have like a Trojan in there and you might not be able to tell because it is so hard. And that's why we see so much buggy code out there. But if you ask your language model to find bugs and point them out to you, once you've seen the bug, it's so much easier for you to say, oh yeah, this was a bug, please fix it. And so now you've taken the task of code base down to, well, I just have to evaluate whether that was a bug according to the spec that I had in mind. And so the general principle that we are excited about here is like we want to leverage AI assistance for human evaluation. And so the hope is that we together, if we pair up humans with AI, you actually get a line that looks more like this, where like humans together with the AI can evaluate much more than they could on their own. And so to make this concrete, there's like 2 different ways you could do that, or there's many different ways you could do that. 2 I want to highlight. It's like first, you can ask AI to write a critique. This is a project we did last year. And in this case, it was a simple summarization task, and we trained a language model to kind of like just say things that are wrong with the summary. And there's other things you could do. For example, you could give people ChatGPT and ask them, okay, use ChatGPT to help you evaluate. And then you could ask for a critique, or you could ask for a lot of other things. You could ask for an explanation. You can ask for fact checking or a quote, or whatever the model like ChatGPT can actually reliably help you with. And so the idea would be that like using AI assistance, you can kind of get all the smarts that AI has and leverage that in order to figure out how you should evaluate what this system is doing, and like whether it's aligned with your preferences or whether it's trying to deceive you. And the big problem with this is, how do we know whether it's working? And one of the kind of like difficulties is that by assumption, we're kind of dealing with a hard task where it's difficult to evaluate. And we also want the task to be real, because we don't want to, we don't want to solve some tight task that doesn't matter. And so it becomes different. So you need a hard task that is real, but also if you have those, you usually don't have ground truth. So you don't know which was the right answer, and how do you know whether assistance is working or it's biasing everyone to just say the same thing? And so there's a simple technique that we used in the critique to do this, that we call targeted perturbations. And so what you do is you have a bunch of prompts. So this could be like whatever people type into ChatGPT. And then you kind of like take the response that you have and you say like, this is the correct response. It doesn't actually have to be correct, but let's just assume it is. And now you're asking a human to introduce some kind of subtle flaw that is easy to miss, but is an important flaw. And now what you have is you have this paired data set of like a good response and a bad response. And you know which one is good and bad because you made it worse. And so, in a way that gives you ground truth. And so what you now can do is you can randomly select either the correct or the flawed response, and then show it to either a human or a human with assistance. And then they have to say whether it was the correct or the flawed one, or like how good the response is. And in this setting, we can kind of just try a lot of different AI assistance or scalable oversight techniques, and then say, is this actually helping humans find the flaws that we planted more reliably than not? And if it is, then, you're actually really helping. And so we did this in the critiques paper. So this is training the language models to write critiques and for summaries. And what we can show is that when we are assisting humans with critiques at the evaluation, they actually find 50% more flaws than they did without. And so this is kind of like real signs of life that you can already use in models that we can have today to help humans evaluate and find problems they would have missed otherwise. And of course, we still have to do this on a much harder task and with a real task in a sense. And we also want to have bigger effect size. But I think it's just it shows that there's promise of these techniques already working. And so in the long run, what I think we want to get to is we kind of want to leverage AI for all the cognitive labor that goes into evaluating whatever our AI systems are doing. And this could be, like reading everything that's relevant, or fact checking, or doing calculations, or like writing code, or any of these things. And then humans should focus on like their preference input, like the things, figuring out what they actually care about and what they want the model to do. And this way we can kind of like leverage, like the abilities that, the AI players will bring to the table, and the things that they will be better at than us eventually. And then kind of like use them to help communicate the thing that we actually care about, and the things that we actually want them to do. And yeah, that's it. But yeah, those are like the main slides. I'm happy to take more questions. Yes.
I was wondering about this hallucination of responses. Have you ever tried to consider some notion of uncertainty in the answers?
Yes.
For example, batch ensembling or something like this, where you can evaluate the variance between the responses and somehow evaluate their uncertainty.
So ensembling is difficult because either you're like training and fine-tuning ensemble from a same pre-trained model, and so you don't get that much variance in your ensemble, or you're pre-training a bunch of different models, and now you're just spending a lot of money on pre-training. One thing, it seems like it should be a solvable problem to just teach the model to say it's uncertain when it's actually uncertain. And there's been a bunch of research in that direction, but I think right now it's still like we're not really in a good shape. It's more stuff to do. Yeah.
Do you think we may run into a kind of signal to noise ratio problem when it comes to AI suggested critiques to AI answers? Because sure, like when AI is trying to point out potential problems with text, humans are more likely to report more problems. But what if it's noticing problems that humans wouldn't have necessarily had a problem with to begin with?
Yeah. So we did try to control for that a little bit by like having humans rate the severity of the flaws and whether they would have noticed them otherwise. You can still see a significant effect. But also, like, a lot of the time the model is nitpicking, and then those are like not the interesting cases.
Yeah.
Also, if you like look at the example I showed, which I think is from the blog post, like a lot of the critiques are just actually quite garbage. And one of the like things that makes it easy for critiques is it's okay if most of them are garbage because the human can just read them and discard them, and it kind of like more helps the evaluator know where to focus on, or like notice, like think of something they would have missed otherwise. So it's more like the critiques help you brainstorm how you should evaluate or something. But if you're kind of like using an assistant, you probably want more reliability than like throwing most of the answers away. Yeah. Yes.
How do we ensure that the evaluation metrics we are using in your recursive reward modeling approach, like detect deception or like left turns or something, don't have like major discontinuity?
Yeah, I think. Well, it depends a lot what kind of discontinuity you're talking about, right? Like if you get overnight like a model that is, let's say, 1,000 inches larger on like number of parameters, or like equivalently better, that can like create quite a step up, and that makes it quite difficult to do this kind of evaluation. So in that sense, I think it's going to be very important to like scale up AI more continuously and like do more incremental steps. Having said that, I think the basic picture with recursive reward modeling is that you're training the systems to help you evaluate, systems that are trained from or fine-tuned from the same system, right? And so if you can figure out how to get like fine tune them in the way that they mention everything that is actually useful and relevant, then it would still be able to evaluate systems, even though they're much smarter than anything you've evaluated before. Maybe let me make that more concrete, because there's, I think, a way that you could measure that, or like one way we've tried it was using what we call the discriminator critique gap. So to measure that, you're training you're fine-tuning two different models from the same pre-trained model. One is a discriminator, that says like, is this the flawed response or the correct response, or more correct response? And the other one is a critique model that tells you what the flaw was. And now you can measure how often did the discriminator get it correctly. And the discriminator is just like pure gradient descent. It doesn't have to want to tell you anything. You're just basically hooking into the model's representations and trying to like get all the relevant latent insight it has to this prediction task. And then on the other hand, you have this critique model or this general assistance model, and you're measuring how often does the assistant actually help me point to the right flaw. And then if you compare these two scores, you can like look at the gap between them, hence this discriminator critique gap. And then if the gap is large, then the model knows a lot about the task it's not telling you. And so that would be very worrying. And if the gap is small, then presumably there's like fewer things that the model is like not telling you.
Yeah, but I guess there's like lots of value in like ensuring this approach is like robust and like and testing it on current models.
That's right. That's why we want to test it on current models. Yes, I don't know who was first. I think someone in the back. Yeah.
Hi. So I wanted to ask about like maybe towards the end you had a slide where like there's like humans shown as like community preferences. And so I couldn't help but notice like part of that also is like communicating what you want the AI to do, right?
That's right.
Not just like evaluating, but like communicating like perhaps like I would like you to do this, and maybe it can't do that. And so like at least like in my personal experience using the ChatGPT, like there were some things that could do that that were like surprising, like you could like simulate the terminal, for instance, and I was like, oh, like how did that come up? Or like you can ask about like it's like in the prompt. There's like different things, right? Where I'm like, okay, like what can I ask for, and like what is that? Yeah. One thing that I thought was a bit concerning was just this idea that like people don't always communicate their preferences like honestly, or like there could be like coordinated efforts, right, to like instill rewards for like specific capabilities, like a coordinated effort to do such a thing. Like, one idea like I had this was like I tried to ask if it has like some idea of like a Wikipedia for itself, right? I didn't know how to use it at first, so I just thought like maybe they put in a user manual. There didn't seem to be one, but like I was hoping there was one. There was one for like GPT-3, right? Like I think Brockman wrote like a little unofficial Wikipedia, so I was hoping. And so my question is like, how do you like make that sort of like thing safe, right? Like how do you like recognize coordinated efforts to like specifically reward certain kinds of behavior? Maybe like some group on 4chan decides that they would like to give it some capability.
So this is this is a really good question. And like in a way, I mean the first obvious thing that you shouldn't do is like you shouldn't just like literally train on the data that people give who like using the interface. And we've kind of like seen other examples of what happens if you do that. If you think of like Microsoft Tay or something, that can go pretty wrong. The other thing is, I mean, right now what we're doing is like we're hiring a bunch of people and then ask them to rate different model responses. But also now the question becomes like, who are we hiring and like what's their background, what are they trying to do? And so, and in particular, like the thing I think we're doing quite poorly right now is like actually like importing like a diverse and representative set of human preferences. And it's more just like, whoever we can hire. And so I kind of wish there was also just like more targeted research on like how we should do that and how that could be done well. And some of it is also like, better placed outside of like big tech companies, because if you are like tech companies always have an incentive to like, import human preferences in a way that maybe is not like the thing that we actually humanity would do under reflection or something. And so I think it's a really big, important question.
There's a slight follow-up, like data contamination is like the dual problem to this. Like, do you think the internet might become contaminated with?
Probably is. Yeah. I mean,
do you have like, is that something?
Anyone can poison pre-training, right? Just put something on the internet. And it's, something that we have to be very mindful of. Yes. I don't know.
Have you thought much about like, considering that we're currently training these models of working relation, all these things are hopefully getting closer to human preferences at this point. As human preferences change, as we've seen like in the past, quite drastically, is there something is there a paradigm or is there a way you can make sure that the models keeping up to date with that, or like what are your thoughts around that?
Yeah, I mean the most obvious thing is it's like the model's knowledge base is kind of like the pre-training cutoff date. Like somebody, whatever data you went into pre-training, it doesn't know about like a lot of things that happened after that. In terms of updating kind of like human preferences or the, like the comparisons that go into the reward model, you just collect more data and retrain. The fine-tuning run is like comparatively cheap, so you can, do that again. I think what gets harder is that, like as you've deployed the model and people started using it for all kinds of, tasks that they want to build their company around, like they, if you update and you change the model, then they also have to do a bunch of work into like adapting their prompts to whatever they're doing. And so it doesn't come at a zero cost. Yes. Sorry, you.
So on the note of exceeding human level performance, but what if the advantage of GPT-3 is that it has this immense corpus of basically the entire internet? If you want to specialize in a specific domain, like chemistry or material science or something, and potentially to generate new compounds or something, then do you think it can be adapted, like to use less data and still learn as efficiently? Same kind of guidance.
You mean like less data on like the chemical domain or something?
Yeah, well, then you maybe just have like research papers over the last 30 years or something.
Yeah. And you can throw that into pre-training, right? And then the model knows about it.
But can the model really learn as effectively without so much data? Or can it be somehow adapt the abstract concepts behind GPT-3 for that simple?
Yeah, I mean, that's kind of the general idea with what you intend to do with fine-tuning. And to some extent, we've seen it like generalized in this way. For example, InstructGPT was trained almost entirely on English language feedback and demonstrations. And it works in other languages. And so that's kind of wild. And so similarly, you could train the model with people who don't know anything about chemistry, and then, it learns to follow instructions and it will do so like on the topic of chemistry. And this fine-tuning can be very sample efficient. Like with 100 data points, you can actually make a meaningful change in the model behavior. So it can be quite effective. I'm gonna pick someone who hasn't asked. Yes.
Regarding response generation, do you or how much effort do you put on, or do you put emphasis in training on different expression styles? So what I've noticed from ChatGPT, that it always gives you back very structured or scientifically structured answers. Do you consider in the training if it returns you like a scientifically structured answer or rather an abstract answer?
Yeah. I mean, the tricky thing is ideally the model should give you the kind of answer that you want to have, right? And some people prefer a more scientific or technical answer. Some people might prefer a more generic answer. And I mean, right now, like ChatGPT doesn't have like, a way for you to set like your specific preferences. And that's something that, would be really exciting to have. But also, I think the kind of stylistic property that you've observed is in fact like probably a product of our labeler pool. And so a lot of the ChatGPT workers were like more, like I think more like computer sciencey and like there was like more data generated by programmers compared to InstructGPT, which was more like generalist labelers. And yeah, there's like different, it's like kind of, it changes also the style.
So there is no specific effort to distinguish that, but depends.
Yeah, I mean, we should make a distinguished effort. It should give you like the style that you want, right? Yes.
So one of the things that I've been thinking about recently is how ChatGPT is going to play a factor in the education of younger generation or coming generation. And so if you go back to the graph of the AI progress and the human level, what humans can evaluate. What I'm starting to think about is like over break, I introduced, as I showed, like my 10-year-old cousin had her ChatGPT just to mess around with. And that green line is a lot lower, right? And furthermore, if say this becomes part of their educational experience, it's going to be I perceive it to be more difficult for them to discriminate even simpler tasks than what we do now. And so I'm already thinking about like how that might disrupt or make this alignment a little bit more difficult in the long run, as you have people who are more, who take, for instance, what ChatGPT says as like a given truth anyway.
Yep.
I was just wondering what your thoughts are.
I mean, there's a real risk of overlying on a tech that is immature and that is not ready for, you just believing like, please don't believe everything the model says, right?
Right.
But also, I think one thing that I'm hopeful for is that like, your cousin will end up like figuring out how to do this, where like, they grew up with, like all of these AI tools that are getting better and learning how to actually leverage them productively, right? And like, it's kind of like, 20 years ago or something, when you were like, using Google search much earlier than everyone else, you're probably going to get better at like using that as a tool for everything you want to do.
Two more questions.
I think you had your hand up for a while.
Like the slide where the human tasks and the chat tasks and the model tasks, right? The AI tasks.
Oh wait, the last one?
The last one. Yeah, so right now it seems like you guys are using humans as biological sensors for the real world, to like physical ground truth, and using language as like a compressed interface to that ground truth. Are you guys also looking at using like sensor technology directly with your models to get a more truthful answer of,
Yeah.
What?
I mean, it depends on what that sensor could be, right? Like, I guess like one of the most straightforward things is you could ask the model to browse, and then it can like fact check its own answers, and it can, like import external knowledge that it didn't remember. And I think that would be quite useful. I think that would also be quite useful for assisting human evaluation.
Does that open work?
You can look at WebGPT, which is a published work on using the model for browsing. I think so. One thing that makes it harder when you're using this like external sensors, or if you're letting the model interact more directly with the real world, is that it raises more safety questions, right? If you let your language model make arbitrary API calls, then you have to be a lot more careful with which calls it's allowed to make and which is it not. And if you're, as opposed to if you just like reviewing everything the model says, then you can decide which ones you want to make. So yeah, it's an open problem. Okay, one more question. I think you didn't.
About the reasoning abilities of these large language models. I've seen like different people talk about how it's only like a fixed amount of compute per token, while like humans, they have system 1 and system 2 where we can like just speak quickly versus like actually do some reasoning and think through things that takes more effort. And then I've seen other works to try to like kind of force it to a chain of prompt or a chain of like reasoning or like let's think step by step and stuff. Do you think that stuff is sufficient to really get reasoning that's to the level that we want, or will it require real big fine tuning or architectural changes?
I don't know. I'm also the wrong person to ask. I'm mostly not trying to get the models to have new capabilities and more like, getting them to play on Team Human. Do we want to do the online questions?
Sure. Yeah. So that also makes sense, but not one of my questions. So what do you think is there a role for offline auto in training from human feedback, especially if you have like if you want to train chatbots, it's hard to model human interactions. So do you think like instead of PPA, you can do more offline auto?
Yeah, quite possibly. I mean, yeah, as you point out, right? Like there is a lot of conversational data, and if you can use it, that should be useful. I think broadly you can categorize this kind of thing as like, let's make the RL algorithm better and like RL feedback. And I think that's valuable, and that should help us like make the same pre-trained models like more aligned according to the human preferences that we collected. But also, you would still run into like all the limitations that RLHF has, right?
Also, if like someone wants to use RLHF on like a GPT-3 model, will OpenAI offer some sort of API for that?
I think there's a fine-tuning API for GPT-3. I don't think it offers RL right now.
Got it.
But it's supervised fine-tuning, so you could do like, you can like distill best of n and do this kind of expert iteration RL.
Got it. Sure. We'll move on to the questions. So the first question is, could you more clearly describe the full training process for ChatGPT? Example, starting with the text Da Vinci 001, then XTD of programming data via steps of high left.
Sorry, I didn't catch that. Start with text Da Vinci 001, and then.
So how much TBs of data do you use, and how many steps of high left kind of things?
I think the exact numbers are not public. It's basically similar to InstructGPT. And for the InstructGPT numbers, we had, I think, around 50,000 comparisons and probably like 10,000 demonstrations, or like maybe tens of thousands. I don't remember the exact number. So I had like this other slide with, it was like about 20,000 hours of human feedback is what I calculated.
And do you think it's possible to crowdsource human feedback? Because you can get like 1 million or whatever interactions you want.
Right. I mean, the big question is like, how do you ensure quality?
Some sort of flip model that can filter out your rankings or something.
But it's the whole problem, right? Like that assumes you already have the reward model that you trust. So.
Okay. Sure. So the next question I think also before was, you want to automate alignment research. What happens if you need conceptual breakthroughs, which are difficult for experts to verify?
Yeah. So, I mean, the kind of like ambition of that plan is to train a model that can do this kind of conceptual research. And, you can picture it like a language model that writes an alignment research paper that we read, and then we're like, oh, this is a really cool idea, we should try this. And I think, going back to evaluation is easier in generation. I think it also applies to alignment research. And I think at the very least, I find it much easier to evaluate, alignment research than I find it to produce it. And so while there might be conceptual breakthroughs that we need that we couldn't even evaluate right now because they're just if we saw them, we'd be like, what is this? And this is kind of like this is like the reason why we want to do scalable oversight, right? Because like if the language model produces this really brilliant insight and we can't even recognize it at the time, we should be able to have an easier time recognizing it if we use the AI assistants and if we leverage like our best AI models to like figure out whether or not that was a good idea, what is the weaknesses and what are the strengths, and like what kind of experiments should we run to know whether this is a good idea. And so I think basically the story of just using RLHF to train a model to do good alignment research, you have the obvious pitfalls, which is the model might write like an alignment proposal that kind of looks good to us but is actually not a good proposal, and it creates AI that is misaligned with humans. And so in order to distinguish the two, which might be really hard, maybe it's not, but I think we should expect it to be really hard, and then leveraging AI assistants to evaluate that seems like a really promising plan.
So if you were to think about like AGI, using RLHF will be the way to scale the system.
I mean, that was my whole point. It's not sufficient.
But do you think like do you need like something more, or if you think about like what OpenAI is trying to do, do you think like if you can like get a lot of feedback data, will that be sufficient to get like very generations, or do you see more ingredients that are missing?
I mean, the generalness, or like, I think the basically the vast majority of the model's capabilities and like all the cool things you see it do come from pre-training and not from the fine-tuning stage. The reason why people sometimes attribute it to the fine-tuning stage is that you didn't see it in the pre-trained model. And the reason that we didn't see it in the pre-trained model is because the pre-trained model was so misaligned. It was not trying to help you and was not trying to show you all the things it can do. And instead, it just regurgitates a bunch of random web text. And that's not what you're looking for. And so, I think that what RLHF basically has been doing is like unlocking capabilities that were already in the model and making those available for humans to use. And in some ways, like, alignment research is very dual use in the sense that, if you have really good alignment techniques, you can use it to align with whatever values you want, including values that, we wouldn't particularly endorse. And B, it also, like, if you're doing alignment right, it will always look a little bit like you made the AI system more capable, because before it wasn't really trying that hard to help you, and now you made it more aligned. So, you actually see these capabilities you already had.
Sure. Let's see. I think this was also a question before. How we deal with RLHF treatment. So this was like reference sort of the proximal values, but optimizing for them to incentivize deception. So how we counter that?
Yeah, so that was what I was talking about here, right? Like, this is like the whole problem that we have, where what humans can evaluate is constant, and so we won't be able to evaluate like sophisticated attempts at deceiving us. And that's why we want to do scalable supervision, so that we empower humans to spot these attempts at deception.
How will your plan for countering inner misalignments stand up to auto-induced distributional shifts in a world quickly changing because of other AI systems?
Yeah, so I think these are real worries, and to some extent, we kind of like have to test empirically, like how difficult and how severe they actually are. I think so. My personal stance right now is something like, I think trying to get the outer alignment signal really right is going to be like 90% of the effort. And once we have that, then a lot of the other things might also fall into place. So for example, I mean, it kind of depends on which story of inner misalignment you're worried about. But, one story is you kind of training your system and it learns how to do, it learns basically a bunch of inner optimizers, kind of like meta reinforcement learning. So for example, like GPT-3 can do like in-context learning. And that's like a kind of, learned optimizer. And so now you're like doing OLHF training or whatever like alignment training you have, and you're like the learned optimizers learn to do the thing that you want on distribution. But now if you have a distributional shift, and this distributional shift could be auto-induced, meaning like the model is causing it itself. And now you're going out of distribution, all these inner optimizers like try to optimize for something else. And one way you could like, and like how much that would actually happen in practice is kind of unclear. But one kind of like more important question is like, if you have a really reliable outer alignment signal and you have this like general training signal that you trust, you can also use that, on the new distribution to train the system to be more, or like to get its inner optimizers in a row, basically. And so then you've reduced like the inner alignment problems to like, how do you deal with a distributional shift, and how do you like construct an outer alignment signal that you trust? And those are problems that we have to deal with anyways. But yeah, I don't know how it's actually going to shake out, but there's some important open questions.
So regarding alignment, one of the kind of problems that I've been encountering in this discussion is there's not much interest, it seems, in like explaining why to come to these judgments or these lack thereof. I was wondering if there's been much interest in OpenAI for decomposing these models and like explaining why this even set constraints arbitrarily. And that's definitely a fruitful route, as your work shows. But as to why it's making these unaligned judgments, have you all been able to interrogate the model?
I mean, I think where we are right now is like pretty satisfactory. I mean, you can ask the model why it gave a certain response, but you don't know whether it's answering truthfully. And you can also, I mean, another thing you can do is you can give the model its own response and ask it to find out flaws, which is what we did in the critiques paper. But, I think there's one version where you try to make that better, but then the question is like, what is your ground truth signal? I think a better angle of attack is probably interpretability, where you figure out how to look inside the model and then how it actually works.
That's what I was asking about. Like the level of research of interpretability.
Yeah,
it's like it seems as though that's been really difficult to do for these large language models in particular, because it has such a high dimensional space.
Yeah.
Your current thinking is moving towards, for lack of a better phrase, like reducing the dimensionality of that representation, something that can be interrogated by people.
Yeah, I mean, we are working on that problem, but I don't think we have anything that is to show right now. And so it seems generally not to be a very easy problem. But I'm hopeful that we can do some things. I think in general, the problem of interpretability, or using interpretability for alignment, is kind of tricky, because I suspect it's going to be not sufficient, and it might not be necessary. So any amount of interpretability you can leverage would be useful, because it's another tool in your toolbox of detecting deception, or knowing, what you said, why the model gave a certain answer and made a certain decision. But it is kind of unclear, if you really get really good at interpretability, how you then leverage that for alignment. Presumably you could look in the model and just throw all the models out that you can find a misalignment in, but then aren't you just selecting for models that have misalignments that are really hard to find with your interpretability tools?
Sure. Just one follow-up to that is, the reason why I asked about that is kind of standard practice in ethics in general is that you have to provide explanation on the problem.
Yeah.
And I guess then my question would be why would you think that interpretability would not be necessary?
Yes. So why would it not be necessary? So again, this is kind of an open question, but basically what stance you could take is that at the end of the day, what really is going to matter is the decisions that the model actually takes and not the reasons why it took them. And so if you can get to the point where you're confident that all the things the model actually does are aligned with what you want, then does it still matter what the model thinks internally? I don't know.
But you have finite data. You have finite ability to evaluate the morality of the model.
Yeah, that's what we're trying to do, right? Like we're trying to make like a really, really good evaluation signal. And then you can select for, you can train the model to do the things that you want it to do, because you can just always evaluate better than the model can do stuff. Yeah.
I would probably have much about that. It's a testing question.
I think
we're good. But yeah, thanks so much,
Thanks a
Leon,
lot.
for the great
Yeah.
lecture. Very interesting.
I might actually do like as we're talking about like the topic of ChatGPT, I might just do like a live just like a application thing.
Yeah, sure.
Just to end of our class.
Sorry.
So how do you think this thing?
Oh, you need
While we're transitioning, should we give our speaker a round of applause?